The ever-increasing number of digital image and video archives has motivated research of new machines that allow to automatically recognize and classify visual content even at large scale. A recent development, the bag of words model for image content representation, combined with advanced classification techniques, allow to automatize the process of the annotation of visual content. Originally, the bag of words model was used to represent content of the text document as an unordered collection of words that are then used for document classification. Similarly, this model can be applied to image analysis through the definition of visual words based on the extraction of visual features related to interest points that represent an object. Visual words are image patches or fragments. Firstly, we learn a dictionary of visual words, for example through clustering. Each cluster center is used as an iconic word. When analyzing an image, the visual features are assigned to the nearest visual word of the dictionary. For each image, we build an histogram that counts the frequency of the occurrence of the visual words. Since we do not take into account the position of these visual words, each image is represented as a bag. The histograms of visual words obtained from the bag of words of images are used to recognize the presence of one or more objects within an image using classification engines referred to as classifiers. A classifier requires a training stage in which it learns how to recognize a concept, typically using a set of manually annotated training data. SVMs are one of the most used classifiers. The idea is that, given a set of training examples marked as belonging to some categories and representing these examples as points in space, we learn an hyperplane that separates these categories by a clear gap that is as wide as possible. Once a classifier has been trained, we can use it to classify the content of new images that are part of a test set. The bag of words approach is currently considered state-of-the-art, but research is still going on. We want to improve object localization, reduce the need of training data, and improve classification and performance.